have size limits which lead to special categories of bulk carrier. Dunkirk-Max ships are sized to fit into the Eastern Harbour lock in the port of Dunkirk. Kamsar-Max bulk carriers have a maximum length that is suitable for berthing at the port of Kamsar in the Republic of Guinea. This is a major loading terminal for bauxite. Newcastle ships are sized so as just to be able to enter the coal port of Newcastle, Australia. Seaway Max ships are the largest that can pass through the canal locks of the St. Lawrence Seaway into the Lakes. And Sitoshi Max ships are the largest vessels that navigate the Sitoshi Sea in Japan. The glossary contains more details of the size restrictions in these ports. The design of a bulk carrier depends on the type of cargo it will carry. Ore, coal, and grain are called the major bulks. These three make up about 2/3 of all dry bulk shipped. Other bulk cargoes are called the minor bulks. The most important factor is the cargo's density. Densities for bulk cargoes vary from 0.6 tons per cubic metre for cargoes like grain to 3 tons per cubic metre for cargoes like ore. Coal, grain and minor bulks can be shipped in bulk carriers of single hull or double construction. Ore is heavier and needs a double hull. Particular design features that are specific to bulk carriers are the sloping hopper tanks, which are used for water ballast. The topside tanks allow ballast to be used to raise the ship's centre of gravity when carrying heavy cargoes. And they also help to limit cargo movement when lower density cargoes are carried. The hopper sides give a sloped surface, which helps cargo flow to the centre of the hold for easier discharge. To help with easy cargo discharge by grab, the holds have wide hatchways, which run between the topside tanks. The hatches are usually about 60% of the length of the hold. Where possible, shedding plates are fitted to the internal hold structures in places where cargo residues might stick. These help to make hold cleaning easier. Any type of bulk carrier can be built with a double hull, but they are always fitted to the larger types. The two hulls are usually about 1 metre apart. They improve safety and provide structural strength and reliability. They also reduce the possibility of damage from accidental flooding. Placing structures such as frames and brackets inside the double hull structure gives a smooth surface in the hold, helping with hold cleaning and also inspection and maintenance. Damage to the ship's structure caused by cargo gear like grabs or bulldozers is also reduced, increasing the speed of cargo discharging in port. The double hull bases give added ballast capacity, which is often linked to the topside and or hopper tanks. This may be an added advantage for ballast voyages. In the case of dedicated ore carriers, the double hull is replaced by side tanks, which are usually much wider than a double hull side shell. The double bottom is also deeper to provide structural strength, and this also raises the centre of gravity of the cargo. Deeper double bottoms in larger bulk carriers also provide space for a duct keel to be arranged along the ship's centre line. This gives a convenient route for piping systems along the ship's length.